మన దగ్గర కూడా ఉంది కదా ఇలాంటిది ఏదాది అనుకుందా.
So, okay, right. Only 7 members is there. Good morning to everyone. So, where is remaining people? Okay, now let's start. Today topic is C8 paper that in that global warming, right? So the unit 1, Earth radiation or energy budget and greenhouse effect. Okay. So first of all, we are going to Earth radiation or energy budget. Okay. So almost all of the Earth surface energy comes from which place? Sun, right? So without the sun, the Earth would be, what happens there? Freeze over and have a temperature below how much? Minus 260 degree Celsius, right? So the energy entering, those are reflected, scattered, and absorbed. So by the Earth system. Okay. So now what is the introduction of the Earth radiation or energy budget? So the Earth energy budget refers to the tracking. So tracking of how much energy is flowing into and out of the Earth climate, right? So where the energy is going and if the energy is coming in balances with the energy going out. So the Earth receives energy from the which place? Sun, right? And it also reflects and radiates energy back into space. So this balance is incoming and outgoing energy creates our climate that supports life as we know it on Earth, right? So the law of conservation of energy states that energy can neither be created nor destroyed. So, but it can be transformed from one state to another. So the energy from the sun is delivered as light energy and some of that energy is used to warm the earth. So, and the differences in densities of air and water between warm and cold regions of the atmosphere and oceans induce currents. So the heat also drives the evaporation of water from the oceans and drives the water cycle, right? So some light energy is converted into which one? Chemical energy. So through which process? photosynthesis, right? Photosynthesis. And also stored as biomass. Stored as biomass. So all of the energy that warms the atmosphere, oceans, and land must be radiated back into the space in order to maintain our current climate system, right? So if the amount of energy radiating back into space that is decreased by even a very small amount, so it can lead to warming. So it is believed that increasing levels of carbon dioxide means CO2, right? CO2. Sorry. CO2, carbon dioxide in the atmosphere. It has a greenhouse effect of reducing the amount of energy radiated into space, right? So now what is reflected? What is reflected? So it means, for example, you see here, this one, if you think about a mirror, right? And you think about you looking in a mirror and you see your image reflected back to you from the mirror, right? So, and in this sense, some of the radiant energy entering, entering into the Earth atmosphere from the sun. So is in fact reflected back, right? So if we think about the sun, here is atmosphere and some clouds in the atmosphere, we have some solar radiation. So that comes through. So we have some solar radiation that is reflected back out into space, right? So, but not uh, just from the clouds, but also from the dust and dirt in the atmosphere. So the dust and dirt in the atmosphere will also reflect some of that radiant energy back out. So while some is getting through and going all the way down to the surface, right? So now, what is absorption or absorb? So it means that there is an energy transformation, right? And this energy transformation is going to be radiant, right? Radiant energy to thermal energy, right? Thermal energy or heat energy. So which is absorbed by the surface, right? So now we are going to, in this radiant or radiation budget, so now you see here, so there is incoming radiations is there and outgoing radiation or solar radiation is there, right? So first of all, we are going to incoming solar radiation, right? Incoming solar radiation. So it's called short wave radiation also, short wave radiation. So most of the incoming energy is in short wave from such as ultraviolet rays and visible rays. From the which place? From the sun, right? The Earth's climate system, right? So some of this incoming radiation is reflected, right? Reflected of clouds. Some is absorbed by the atmosphere and some passes through to the Earth surface, right? So approximately the globally and annually 51% of the solar radiation striking the Earth and its atmosphere is absorbed at the surface, right? So the atmosphere absorbs 19% of incoming solar and the remaining 30 is reflected back into the space. So the shortest wavelengths of solar radiation, it means those are most dangerous to our life, right? So those are absorbed by molecules in the upper and middle atmosphere. So in particular, the ozone selectively absorbs ultraviolet radiation, right? So while allowing visible radiation to pass through relatively unhindered, right? So the reflection significantly affects the solar radiation that reaches the ground, as the sun's rays could be reflected off of air molecules, clouds, or the ground itself, right? So now the light color are shiny objects. So those are reflect more radiation than dark objects, right? So the energy that is reflected cannot be absorbed or transmitted through an object that is dark color, right? So now you see this picture. So in this picture, we can find incoming and outgoing radiations is there. So yellow arrow showing incoming radiation. Hey, Chaitra, sound of this incoming radiation. So this red color arrow showing outgoing energy, right? So now I can explain about this picture briefly. Okay. So the total Earth energy budget, so you can explain from this figure only. Okay. So this is important question. In your examination, we are asking Earth energy budget or Earth radiation budget. So you can explain this about this. So I will tell you now. So how to explain about this Earth energy budget, right? So now you see, so this bifurcation of this outgoing and incoming radiation, okay? So now first important thing is, let us understand it form of this 100 units, right? So the 100 units of the energy that received from the sun, right? So the consider the insolation received at the top of the atmosphere is this 100 units, okay? This 100 units, okay? So now let's divided in this 100 units in different segments and understand how it is divided, and finally how this 100 units incoming is actually equivalent to 100 outgoing, right? So while passing through the atmosphere, here what happened? There are these processes, those are reflected and scattered and absorbed. So all these process happens, right? So roughly what happens, you see here. So 35 units, 35 units. Now remember, this is out of this 100 units, right? Out of this 100 units, these 35 units are reflected back, okay? Reflected back. So what is left is remaining. So 100 minus 35 equal 65 remaining is there, right? So I will discuss 65. So now these 35 are reflected back to the atmosphere, right? So even before reaching the earth surface, right? So now if you want to learn about the bifurcation of these 35 units, okay? This 35 units only. 30, these 35 units, okay? So how is reflected? So let's see, in this 35 units, so 6 units, you see here 6, these 6 units. 6 units are scattered into space, right? Out of 35, 6 units are gone. So that is scattered into space. And 27 units, right? These 27 units are reflected back from to the top of the clouds only. So the atmosphere are clouds, right? And remaining remaining in out of from 35 minus 6 minus 6 27, so equal to 33, right? So remaining, what is the remaining units? 2 only, right? So these 2 units from the snow and ice covered areas of the earth also go back. So this is important, right? So out of 35, 6 units are scattered and 27 units are reflected back, and 2 units from the snow and ice covered areas of the earth also going back, right? So these 35 units are gone, right? So from 100 units, right? So what we receive already. So now what is remaining out of 100, 35 units are gone and remaining is 65. Okay. 65 units are left, right? So, and this reflected amount of radiation is 35 units are called, these 35 units, these 35 units are called albedo, ALBEDO, right? Albedo, right? So now albedo is basically what? The portion, you see here, the portion of the incident radiation of the energy reflected back from a surface of body is called albedo or reflection coefficient or simple reflectivity, right? Simple reflectivity. So the albedo, reflection and coefficient, remember these terminologies. So reflection coefficient is also be albedo only, right? And simply reflectivity, so it is return reflectivity or it is return albedo or it is reflection coefficient, remember. So it is talking about the same thing, right? Same word. So same meaning. So the albedo can simply define as a measure of how much light that hits a surface is reflected, right? Reflected back without being absorbed, right? Without being absorbed. Remember this. So the albedo is an important concept in environmental management and also climatology and astronomy also, right? And it plays a major role. So major uh, role in the energy balances of the Earth's surface. So as it defines the rate of the absorbed portion of the incident solar radiation. So how much is absorbed, about how much is reflected back by the what surface on the earth. So you remember every surface have given value, a given value, right? So someone has lesser albedo values or someone has greater albedo values, right? So what is the albedo? It is the amount of reflection. So it means body reflection something. So it is reflect 5, right? 5% or 4% or 1%, right? 5 or 4 or 1%. So more reflection value means more albedo value. So reflection coefficient is more. It means it has more tendency to do not absorb, rather that give away, right? So in heat budget, what is the importance now? So you can understand that heat budget is now talking and giving out. So it will all depends upon this surface property, right? So now you see, so 35 units are gone here out of 100, right? So 35 units are called albedo, right? So remaining, how many units are there? 65, right? So 100 minus 35 equal 65 units, right? These 65 units are, okay? So what happens to the remaining 65 units? Because these 35 units are already gone, right? So out of this 35 units, out of this, not only 35, out of this, sorry, 65 units. So remember, 14 units. You see here, 14 units are absorbed within the atmosphere itself, out of 65, right? So when it is reflected back, 35, right? So the remaining 65 is there, out of which absorption happens now. So now, no reflection, remember absorption, right? So absorption happens 14 units were in the atmosphere, and rest of the 51 units, this 51 out of 65. So 14 units are absorbed. And this 55 units by the earth surface, that is very, very important, right? So the earth radiates back those 51 units now. So because what reaches finally the earth is this 51 units, right? So it is obviously reflect back this 51 units only. So these units, these 51 units, these 51 units are radiated to space in the form of terrestrial radiation. Okay, terrestrial radiation. So what is the terrestrial radiation? So it means the heated earth becomes a radiating body, and it radiates energy to the atmosphere in long wave form. So this energy heats up the atmosphere from the below or ground. So this process is known as terrestrial radiation, right? So now this terrestrial radiation, what we need to learn, out of this 51 units, what is the bifurcation for this? So you see here, 17 units. 17 units are radiated back to space directly, right? Out of 51 units, right? Remember, out of 51. So 61 out of 14 and 15 is gone. Now, bifurcation for this 51 units only. Okay, remember this. So out of 51 units, 71 units are radiated back to space directly. And what is the remaining out of this 51? 34, right? Is it right? So 17 are radiated back and 34 units are left. So which are absorbed by the atmosphere while they're going back, right? So remember, atmosphere is very interesting. So while it is taking in, get something. So while it is given out, it is also get something. So at both these stages, incoming stage as well as outgoing stage, atmosphere actually absorbed, right? Actually absorbed. So now, so 51. So 65 is over, and in this 51 is bifurcation is over. So in this 34 units. So again 34 units absorbed by the atmosphere, right? So again, want to bifurcation about 34 units. So in 34 units, 6 units, these 6 units absorbed by the atmosphere directly, and 9 units are through convection and turbulence, right? And remaining 19 units are through latent heat of condensation, right? So up to 34 units are over, right? So finally, you see, so the 48 units are absorbed by the atmosphere if you are looking in the total, right? Total means 100 units, right? So where you remember the first 14 units from the insolation, right? And 34 units from the terrestrial radiation. So the atmosphere is the greatest observer, right? What is this? Atmosphere. Atmosphere is the greatest observer. So this is important. Remember this. So the total, this 48 units of the solar insolation is single-handedly absorbed by the atmosphere itself. And also the same amount is, what happened is that radiated back to the space, right? So the total radiation returning from the earth and atmosphere, respectively, how much? Remember now, this 48 units is coming from the atmosphere and 17 is go back, right? 17 is go back into the space, and the total amount is what? 17 plus 48 is equal to 65 units, right? So this 65 units, okay? Sorry, this one. This 65 units, okay? So now come back to the same 65 units where it started, right? So this is the entire balance between 65 incoming and 65 outgoing out of the 65. So this is bifurcation. So the balance total 65 units are received from which place? Sun, right? Sun. So this balance sheet is called heat budget and also called as heat balance of the earth. So now what we need to do is make a summary. So in this summary was, you see here, this is the summary. So you can easily understand this figure, okay? So what was the incoming and where were the expenditures, right? Okay. So now you see here, what is the, see here 100 units, right? This 100 units are solar insolation, means incoming radiation, right? So now look into this green arrow. So what you see, 65 units. This 65 units reaches the earth. So now this 65 is what happened? 14 units are absorbed by the atmosphere and 51 units who absorbed? Earth, right? So now from this 51 units, what we learn is 17 from 51, 17 is giving back. And so remaining these 34 units are absorbed by the atmosphere, right? Absorbed by the atmosphere. And this 14, so this 14 absorbed by the atmosphere. And so this total absorbed by the atmosphere is how much? This 48 units, and this 14 plus 34 equal 48 units, right? 14 plus 34 units equal to 48 units. So now this 17, you see here, now this 17 is already going back. So how much is left go back is 48 is there. So it is finally going back to space. So 48 plus 17. 48 plus 17. Again, we have 65 units here, right? 65 units. So the entire this arrows is incoming and green arrows is incoming and this yellow arrows is outgoing. So 65 is came and in and 65 is out, right? So the amount of incoming solar energy at the top of the atmosphere is 100% or 100 units. So which means 100% of the sun rays are hitting the exosphere. It is the first outermost layer of the atmosphere. So now while passing through the layers of the atmosphere, some amount of energy reflected, right? Some amount of energy is reflected. You see here, this one. Okay, these blue arrows. Okay. And scattered and absorbed. And only the remaining part reaches the Earth's surface. So the 35% of the reflected radiation is called albedo, 35 units, right, of the Earth. So albedo means what? How much of the sun's energy reflected back into the space, right? So now as the remaining 65% sun rays enter the atmosphere and 14 of it is absorbed, right? This 14 of it is absorbed within the atmosphere by which one? Water vapor and dust particles and other atmospheric gases, right? So now the remaining 51 of sun rays is actually absorbed by the Earth's surface. Now it's time for the Earth to radiate back the 51% of the or 51 units of the heat which is received from the sun. So in other words, we can say it's time for terrestrial radiation. I already told about that, right? This terrestrial radiation. So this time the heat travels in vertical manner and there is a term given to it is called convection, right? Convection, this blue color, convection. So as the heat rises 34, this 34 units or 34% of the heat will be absorbed again by the atmosphere. So which includes water vapor, dust particles and horizontal air movement and other atmospheric gases, right? So the remaining 17% of the heat is radiated to space directly. So if you notice here, the total of 48, right? This 48. So 48 of heat is absorbed by the atmosphere. That is 34 from terrestrial radiation and 14 from incoming solar energy. And this 48 of heat absorbed by the atmosphere is also radiate back into space, right? So now the total radiation is what? 48 plus 17 is equal to 65, right? 65. Okay? 65. And if you remember in this, in the beginning, we have that 65. So 35 is called albedo, right? So that we have 65 of heat makes into the atmosphere. So now what we can conclude from this calculation is that if the amount of heat received in the form of indulation equals the amount lost by the Earth through this terrestrial radiation, which in this case we found it to be equal. So that means the Earth maintains the its temperature, or we can say the Earth neither warms up too much nor too cools down too much, right? So despite the huge transfer of heat that takes place, right? So this is the 100 units bifurcation, right? Heat budget of the energy. So now while outgoing energy, while outgoing radiation is in infrared forms such as infrared, right? Infrared rays, right? So this radiation is also called as long wave, right? Long wave. So incoming radiation is also called, what is that? Short wave radiation, right? So outgoing radiation is also called long wave radiation. Remember this, okay? Don't confuse short wave or long wave. or outgoing and incoming. Okay. So the Earth's surface, atmosphere, and clouds emit radiation in the infrared band and near infrared band. So the outgoing infrared, it means IR, right? So outgoing infrared radiation from the Earth's surface. So that is also we called terrestrial radiation, right? So that is selectively absorbed by certain molecules such as the particularly water vapor and carbon dioxide, right? So gases, some of the gases which absorb infrared radiation are termed collectively as, what is that? Greenhouse gases, right? So this greenhouse gases. So water vapor and carbon dioxide emit infrared radiation. So the infrared radiation from greenhouse gases in the atmosphere is emitted, right? Is emitted in all directions, including back to the earth surface. So it is the re-emission to the earth surface. So that maintains a higher temperature on our planet. So that what would be possible without the atmosphere, right? So the condensed water is also an efficient absorber and emitter of infrared radiation. So thus clouds act in a manner similar to greenhouse gases. So the major atmospheric gases, those are oxygen and nitrogen, those are transparent to incoming sunlight, but those are also transparent to outgoing thermal infrared radiation. So however, the water vapor and carbon dioxide, right? Water vapor and carbon dioxide and methane and also other trace gases. Those are opaque to many wavelengths of thermal radiation, right? Thermal radiation. So the increasing, right? The increasing concentration of greenhouse gases like carbon dioxide, methane, increase the temperature of the lower atmosphere by restricting the outward passage of emitted radiation, resulting, it is called global warming or global climate change, right? So when greenhouse gas molecules absorb the thermal infrared energy and also the temperature will be also raised. So these gases then radiate an increased amount of the thermal infrared energy in all directions, right? So the heat radiated upward continues to encounter greenhouse gas molecules. So those molecules also absorb the heat and the temperature rises and the amount of heat they radiate increases, right? So the atmosphere thins with altitude and at roughly 5 to 6, right? 5 to 6 kilometer. So the concentration of greenhouse gases in the overlying atmosphere is so thin, so that heat can escape to space. So because greenhouse gas molecules radiate infrared energy in all directions. So some of it spread downward and ultimately returns to the earth surface. So where it is observed, right? So the earth surface temperature is thus higher than it would be if it were heated only by direct solar heating. So this supplemental heating is the natural greenhouse effect, right? So it is as if the earth is covered by the blanket that allows high frequency radiation. It is sunlight to enter, but slow the rate at which the low frequency infrared radiant energy emitted by the earth leaves, right? So the atmospheric heat budget of the earth depends on the balance between this insolation and terrestrial radiation, right? Terrestrial radiation. So means the earth radiation budget is the balance between incoming. Insolation means incoming energy from the sun and the outgoing long wave and reflected short wave energy from the earth, right? So this is the earth energy budget and radiation budget. So this is important question, and this is the 15 marks question they're asking in your examination. So any doubts in this radiation budget? Anybody? Anybody? Any doubts?
No, ma'am.
Is it clear?
Yes,
Madam,
ma'am.
I think in the assignment also you have given, madam.
అసైన్మెంట్స్ ఇప్పుడు ఏం లేదండి మీ ఓన్లీ
కాదు అసైన్మెంట్ లో కూడా ఈ క్వశ్చన్ అడిగారు మేడం.
అచ్చా ఓకే ఓకే రేడియేషన్ బడ్జెట్ రైట్
బడ్జెట్ రేడియేషన్ బడ్జెట్ యా
రైట్. సో అండ్ థియరీలో కూడా ఈ క్వశ్చన్ వస్తుంది మీకు, గుర్తుపెట్టుకోండి. సో మీరు టోటల్ రేడియేషన్ బడ్జెట్ అన్నప్పుడు ఈ స్లైడ్ ఉంది కదా, ఈ స్లైడ్ ఇది మీరు విత్ ఫిగర్ మీన్స్ దిస్ ఫిగర్. ఓకే, సో యు డ్రా దిస్ ఫిగర్ అండ్ సో 100 యూనిట్స్ ఉన్నాయి కదా, 100 యూనిట్స్ ని ఎలా బైఫర్కేషన్ చేస్తాము, మన ఇన్కమింగ్ ఎంత, అవుట్ గోయింగ్ ఎంత రేడియేషన్. సో అది మీరు క్లారిటీగా మీరు క్లియర్ కట్ గా మీరు ఎక్స్ప్లెయిన్ చేస్తే మీకు 15 మార్క్స్ కి 14 or 15 కూడా ఇస్తాం. ఓకే 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 రైట్. సో నౌ wait, I will upload another PPT. So this radiation budget is finished. Okay.
మేడం ఇది గ్రూప్ లో కూడా పెట్టండి మేడం.
పెట్టేస్తాను నేను. యాక్చువల్లీ నిన్న నేను అది చెప్పాను మీకు వేరే క్లాస్, అది C6 చెప్పాను, రిమైనింగ్ ఇంకా కొన్ని యూనిట్స్ ఉన్నాయి మీకు. సో అయితే అది మన అశోక్ సార్ కంప్లీట్ చేస్తున్నారు. సో ఇన్ కేస్ ఐ విల్ ఆల్సో రిపీట్ అగైన్. సో ద లాస్ట్ 3 units. So after this C8 paper, okay? Finishing of this C8 paper, I will explain. So in case time unte, meeku explain chestanu, adi kuda meeku PPT upload chesestanu. Okay? Right. So just wait, I will upload another PPT. Right. Okay. So now next topic is sea level rise. So this is also 5 marks question. Okay. So this is also very important. So what is sea level rise? So maximum all of you know about this. So sea level rise is one of the most significant effects of the climate change, right? So the sea level rise, it's called SLR, okay? SLR, sea level rise, okay? So it is the one of the most worrying impacts of global warming, right? So the sea level is the base level for measuring elevation and depth on Earth. So hence the sea level rise is a climate change phenomena through which one? The ocean water volume increases mostly as a consequence of ice sheets and melting of glaciers and thermal water expansion, right? So as a consequence of sea level rising and coastal life around the world is at threatened, and adaptation policies need to be developed to avoid further and faster catastrophic impacts, right? Now you see the definition. What is the sea level definition? You see here, the sea level rise in an increase in global mean sea level as a result of increase in the volume of water in the world's oceans, right? So this is the definition. So the climate change has a significant impact on the sea level changes as well, right? So it means all these attributes. So those are going to be impacted in one way or the other way, directly or indirectly, right? So now if you see this diagram, the climate change has various attributes or various impacts on various attributes. What is that? Precipitation, runoff, and is carbon dioxide levels and sea surface temperatures, right? You see here, okay? And then you have sea level rise, right? Sea level rise, this is important. So where we are concerned right now. And wind waves, this wind waves and storm intensity, right? So now, if you observed, all these factors are importantly related to climate change, right? So if you observe one part, that is sea level rise, how does it influence or impact the various attributes related to the coastal areas, right? These coastal areas. So if you observe one part, that is sea level rise, you see, right? So you understand, first important is where it is linked with sediments, right? This one. So sediments and these nutrients. So which is related directly, which one? Coastal flooding. Then we have wetland production, right? So that is directly impacted by which one? Ocean acidification. So then we have algal blooms. So that is also directly related to which one? Coral bleaching. And we have coastal erosion. So that leads to inundation. Then we have beach rotation, and which is linked to benthic damage. And then we have infrastructure damage that is related to the storms, surge and cyclones. So that we observe here, right? So when we say sea level changes, this sea level changes, it means all these attributes are going to be impacted in one way or the other, directly or indirectly, right? So if you are observe this coastal flooding, and ocean acidification, this coral bleaching, inundation and benthic damage and storm surge. So all these factors are directly or indirectly related to the sea level changes. And why we are worried about this? So because it has been observed that, so due to extreme climate change, due to extreme global warming, the levels of the sea is rising, and it is going to further rise ahead in the coming terms, right? So that is one important point where we are also concerned about it, right? So now let's elaborate further more details. You see, so now, first of all, the sea level rise, SLR, is an increase in the level of the world's oceans due to the effect of climate change, especially global warming, induced by uh, three primary factors. Those are thermal expansion and melting glaciers, and also third one is loss of Greenland and Antarctica's ice sheet, right? So when we say the sea level is basically, what is it? An increase in the level of the world's ocean due to the impacts or effects of climate change, right? So now you see, the first one is thermal expansion, right? So what is this thermal expansion? So now you see, when water heats up, when water heats up, it expands. Expansion means expands, right? So about half to the sea level rise, the past 5 years is attributable to warmer oceans simply occupying more space, right? So when water heats up, what happens to the water? It expands. So when it expands, what will happen? About half of the sea level rise over the past 25 or sorry, not 5 years, this is 25 years. So 25 is going to be attributed. So to what? Warmer oceans. Warmer oceans, it means expanding and it is occupying space, right? So the thermal expansion parts that is giving rise to the sea level, right? So the thermal expansion is the increase of the substance when it's heated, right? We all to know heat expands and cold contracts. So the, yes, who is that? Okay, right. So the reason for the increase in ocean temperatures is due to the increase in atmospheric greenhouse gases, so which began with the Industrial Revolution. So the ultraviolet and infrared and visible radiations. So these are come into the air, and then infrared radiation bounces off of the earth, and instead of bouncing off and leaving at atmosphere, so it gets trapped by the greenhouse gases, right? So that just happen to absorb this exact type of radiation, and how convenient this lead to an increase in atmospheric temperature, and oceans absorb 90% of this heat, right? So this is thermal expansion. And second one is melting glaciers. So it is very, you see here, high temperatures causing so now you see, high temperatures caused by global warming have led to greater than average summer melting of large ice formations like mountain glaciers, as well as diminished snowfall due to later winter and earlier springs. So melting glaciers, it is very commonly understood by all of us, right? So that if glaciers melt due to rising temperatures, right? So what will happen there? It will be rise in the sea level automatically. Why? Why? Because what happens due to the large areas of ice or snow which is melting, right? Which is melting. It will lead to the diminishing of the glaciers, right? Diminishing of the this glaciers. And at the same time, what will happen? It will change the seasonally and seasonal pattern, that is snowfall due to later winters and earlier springs. So that is related to the climate change, right? And also what happens? It leads to an imbalance between the runoff and ocean evaporation. So now remember, runoff is related to the surface water. So that is brought from the river to the ocean. And when we say runoff and ocean evaporation, if this balance is reduced, or if this balance is actually disturbed, so it means that if there is more runoff and if there is less evaporation, right? More runoff and if there is less evaporation. So what will happen? If there is an imbalance, that will lead to sea level rise. So that is one important point here. Okay. So now you see here, apart from the salinity and temperature changes, as that we already know about that. So these are the two major primary factors. Those are this thermal expansion plus melting ice sheet, right? So which are of prime importance in terms of global warming and sea level rise. Okay. So now you see, observe this figure. This is the sea level rise. So some places, okay. And also you observe this melting glaciers. So this is the figure 1941. You see, so these ices is there. So in 2008, same river or something. So you see here. So melting of ice sheets, melting of glaciers. Okay. So now remember, thermal expansion is over and melting glaciers is over. You see here, this one. So third one is Greenland and Antarctica ice sheets. Okay. So the sea level is going up because of the 20th century is experiencing a period of strong global warming, and that leads to the expansion of the ocean waters. Warmer water simply takes up more space, and also it leads to melting of continental ice and the mountain glaciers, the ice sheets in Greenland and Antarctica. So they are all losing ice, and that water ends up in the ocean, pushing up the sea levels. So we know that sea level has risen about how much? 15, right? 15 to 20 centimeters, right? 20 centimeters since the late 19th century, right? 19th century. Okay, that is 15 to 20 centimeters. So the Greenland and Antarctic ice sheets are one of the biggest concern for longer term sea level rise. So with an area of how much? 2.16 million square kilometers, right? Million square kilometers, 2.16. So the 80% of total Greenland is covered by the which one? Ice caps, okay? That is 80%. So with a population of more than how much? 57,000 people only. Okay. So the Greenland ice melted more last year than any year before. It has been found that in the year of 2019. Okay. So the Greenland lost, about 532 billion tons of ice sheet. Okay. So with 223, you see here. Right, you see here. I wrote here 223 billion tons of ice in July alone. Okay. So in case the entire Greenland ice sheet melt. So what happened in the world? Anybody? What happened is that the entire Greenland ice sheet is melt. In case what happened is there? In the world.
So many cities will be disappear
Right.
due to that means this it will sink in the water.
Right. So the so millions of peoples will die also, right? So
Yes,
the
yes.
entire Greenland ice sheet melt, sea level would rise by 6 meters, right? How much? 6 meters worldwide. So millions of peoples will die or dead. So as with mountain glaciers, increased heat is causing the massive ice sheets. So that cover Greenland and Antarctica to melt more quickly and also more quickly into the sea. So remember, if the areas of these particular continental ice sheets means Antarctica and Greenland, right? So the continental ice sheets are exposed to intense heating, what will happen? It will add more volume of water to the sea. So thereby changing the sea level, right? So these are the three major primary factors which are of prime importance in terms of global warming and sea level rise. First one is thermal. Tell me, what is the three primary major factors? I already told, you forgot that. So this one, thermal expansion and melting glaciers, and also third one is Greenland ice sheet. Okay, this one. So now the IPCC report released a special report on ocean in cryosphere, right? So the cryosphere means the cryosphere contains the frozen parts of the planet, right? So it includes snow and ice on land. So ice caps, glaciers, permafrost, and sea ice, right? So in changing climate, which underline these changes taking place in oceans, glaciers, and ice deposits on land and sea. So that is where the concern came from, this particular report by IPCC, right? So what does it say? The report expects that oceans to rise. Okay, no. So rise between how much? 10, right? 10 to 30 inches. 10 to 30 inches by which time? 2100 year, 2100, right? So almost in next 80 years, that is going to rise by 10 to 30 inches because the temperature is warming up to 1.5 degrees centigrade furthermore. Okay. So, if there is 1.5 degrees centigrade rise in temperature, it will lead to about 10 to 30 inches rise in the oceanic area across the world. Remember, okay? 10 to 30 inches. So, that is importantly in terms of sea level rise or sea level changes that we observed around the world ocean according to this IPCC report, right? So now we are going to sorry. Historic changes. Where is historic changes? So what is the historic changes in this sea level rise means? In the past, what we have seen the changes in sea level from IPCC report of 1998 and 2001 and 2004. So what we observed? So since the last glacier maximum. So remember 20,000 years, that is what we say last glaciers maximum happened. So mean sea level has risen by 120 meters, right? 120 meters. That is a great amount of rise if you seen in the last 20,000 years, right? So now you see. So impacts and effects of the sea level. So now the concern is population is human population. So that's where we are more concerned about that, right? So if there is a rise in sea level, what is going to happen? So remember there is a this vulnerable population group, that region in various areas of the world, right? So the vulnerable population regions are populated regions, and their predictions have been mentioned here. If you can observe this figure, okay. So if you see this particular map, this particular coastal parts. So this is India, right? So, this. So these coastal parts of India, which is heavily populated, right? So then again, Southeast Asia, right? Southeast Asia, this one. So is heavily populated, and some parts of Africa, right? This one, and this one. And some parts of South America, and also some parts of North America as well, apart from the this European nations as well, right? So what we see, considerably populations are going to be affected a great deal, right? So that is one important point. So what we observe here, this large coastal cities, right? These are the last coastal cities, that is populations having greater population than how much? 8 million, right? 8 million over 50% of United States population live in coastal areas, right? 50% population are live in coastal areas, right? So that is greater than 110 million, right? 110 million. So that is a huge amount if you observe just for in United States itself, right? And then if you consider the whole world, So it is going to be a huge number that is going to be potentially impacted by the sea level rises. So that's why we are worried about, right? So if you observed highly populated delta regions, right? Highly populated delta regions of the world, remember, the vulnerable to what it means? Mean sea level, right? Mean sea level rise. So if delta regions of the world, those are to be considered, the mean sea level rise is going to impact. So if you see what are going to be the impact, the coastal regions more susceptible to the storm surges and flooding, beach and coastal erosions. So this is going to be impacted, disruption of activities, danger to life and infrastructure damages also. So these are the potential threats to us. So then 1 meter rise in mean sea level, it would be enable 15 years storm flood areas that today those are only flooded by 100 years storms, right? Now you see this figure. If you observe these areas, those are this South Asia, right? This one. So South Asia and Southeast, which is going to be the most vulnerable group, apart from some parts of in Europe, right? This Europe and some parts in America, right? These are. So as well, so that is going to be one of the most important areas, right? So now, what are the effects of sea level rise? First one is urban flooding. So urban flooding, it has become one of the major features, especially on those areas, so which are a part of the coastal cities, right? So you see some pictures of these coastal cities here, right? So in India, tell me some coastal cities. Tell me the names of coastal cities in India. Coastal areas. ఆంధ్ర వాళ్ళు లేరండి? కోస్టల్ ఏరియాస్ నేమ్స్ చెప్పండి. చెన్నై, రైట్. దెన్ నెక్స్ట్ రాకీ చెప్పింది చెన్నై, ముంబై. So right. So because of storm surges and also because of the drainage or waste or sewage systems, right? So that are now contaminated. So we see lots of urban flooding happening as well in future. Remember. So, and flood damages would increase up to how much? 58%, right? 58% for 30 centimeters rise even in sea level. And we are expecting by, in which year? 2100. And how much? About 30 centimeters of rise, sea level rise. So just imagine how much would be the flood damages by these 2100 here at this particular rate. So that is the concern related to vulnerable population regions across the world, right? The next one is, what are the problems related to sea level rise if you observe carefully? The first one is this salt water intrusion also, right? Salt water intrusion. So urban flooding is our next one. Sorry, next one is the salt water intrusion. So the salt water will penetrate further inland and upstream in estuaries. It means so salt water intrusion is going to be the major threat, right? So now, so what will happen? The estuarine area, remember, the estuarine area means where you have, you see here, this is the river and this is the ocean. Okay, this is river and ocean. So river water mixing with the ocean water or sea water. So this place is called, okay, estuarine area, right? Remember this estuarine area, right? So if there is more sea level rise and more inward intrusion of the salt water happens, and that is going to be a problem for the estuarine ecosystem, right? So the balance is going to be deteriorated, right? So the higher salinity impairs both surface water and as well, and not just surface water, we are dependent upon groundwater supply, right? So this saline water, if it comes to the land area, it is going to also impact our groundwater resources, right? So that is going to be a key concern as well. So, and apart from that, salt water intrusion would also harm ecosystems. So in what ways? So what ways means those are aquatic plants and animals. Examples, salt marshes and mangroves, right? And higher salinity. Higher salinity has been found to decrease the seed germination. So there is going to be a lot of problem on agriculture in horticulture, right? Then flooding. Flooded agricultural land takes a long time to recover from saline water, right? The flooded agricultural land takes a long time to actually recover from that salinity water, right? So if there is a salinity increase in the land, you cannot do anything, right? So it is going to be rendered and degraded land, right? So that is the biggest problem that we are going to face if there is going to be a significant rise in sea level in future, right? So now, so problems not directly climate change. What are the problems not directly climate change? So problems not directly climate related, but they are problems, right? They are problems. So తిట్టను పోరా గాడిద కొడుకు అన్నట్టుంది, బట్ తిట్టుడేది. సో రైట్ లైక్ దట్. సో ప్రాబ్లమ్స్ నాట్ డైరెక్ట్లీ climate, but they are problems. So what are those? So the tides, first one is the tides and second one is storm surges, right? So tides, tide means, so that is periodic changes due to changing orbital motions of the earth and moon. So that is going to be also impacted, right? So tide are the periodical rise and fall of the sea levels. So once or twice a day. So caused by the combination effects of the gravitational forces exerted by the sun, the moon, and the rotation of the earth, right? So the figure right. So they are a vertical movement of waters and different from movements of ocean water caused by meteorological effects like the winds and atmospheric pressure changes, right? So now the water movements which are caused by the meteorological effects like the said above are called as surges, right? And they are not regular like tides. Okay. So the moon's gravitational pull to a great extent is the major cause of the occurrence of tides. So it means the moon's gravitational attraction is more effective on the earth than that of the sun, right? The sun's gravitational pull and the centrifugal force due to the rotation of earth are the other forces which act along with the moon's gravitational force pull. So tides are about periodical rise. So the word again is periodical. It means at a given interval or at a particular time period, right? So that is important. And what is it exactly? The fall of sea levels or the rise of sea levels, right? So the rise and fall of sea levels, that is what we understand as tides, right? So, and we already know there is a gravity influenced by the sun and moon on the earth, right? So that is where it is created. Now remember, there are vertical movements of waters. So remember, wave we said it was horizontal movement, but tides are what these are vertical movements, unlike waves. So waves are the horizontal movement. So here is important point to note that water movement which are caused by meteorological effects like said above are called surges, right? So now remember, when there is a tidal action which is vertical, not horizontal, these are also termed as surges, right? So because surge is the upward movement, right? So it is not like a regular tide because of certain meteorological factors as well, the movement of water surges. So during cyclones, we tend to use this word surge as well. So the surge along with the tide, when it combines, it is greater force. So that is what we see, right? So the moon's gravitational pull to a great extent is the major cause of the occurrence of tides. And many people think that only moon is responsible, right? So you remember, this is a myth, and don't confuse yourself that only moon is responsible. Remember, sun is also responsible, not only moon. So not just the moon, but the moon's gravitational attraction is more effective, right? So that is the important point. So because sun is very far away, and remember the concept of gravity, the distance, right? So the distance plays a pivotal role because moon is close to the earth, right? Moon is close to the earth. It has more influence on the earth. So any doubts? పెట్టుకున్నారు. Okay, right. Mute. Wait, batteries. Right? So, the sun's gravitational pull, that is also the centrifugal force due to the rotation of the earth, and that is where it attracts and also leads to the tidal formation. So, but comparing the sun and moon pulls. So, moon is the greater force, that is important. So, the highest tides in the world occurs in the Bay of Fundy in Canada. So, mute పెట్టుకోలేరా? Right. The highest tide in the world, that is Bay of Fundy. Bay of Fundy, F-U-N-D-I, Fundy in Canada. Okay, that is the highest tide. Okay, and storm surges like atmospheric effects are also going to be there, right? So inverse barometer and tropical storm or hurricane surges, so these are going to be a part of these impacts, so which are not directly related to climate, but there is a impact, right? So then wind stress driven surge is also going to impact. So you see here, these are the directly climate related impact to climate change, right? So these are not directly, and these are directly, okay? Directly impacts. So those are isostatic and eustatic and steric. These three are the very important, right? So what is isostatic? Isostatic means, what is that isostatic level changes, which we all already discussed in details in a previous class. So in isostatic morphology, that is vertical movement of the land. What is that? Vertical movement of the land. So in eustatic means, that is changes of total seawater mass. Total seawater mass, right? So that is going to impact is as well. And steric. Steric means that is thermal expansion. Thermal expansion of water volume, right? So these changes, isostatic changes, eustatic changes, and steric changes. So these are directly related to the climatic changes that we observed in the oceans, right? So this is going to be the greatest impact, right? And now I think time is up. సో తను ఎవరో మెసేజ్ పెట్టారు, ఎవరు విశాఖపట్నం నుండి సూరిబాబు గొల్ల. సో ఏమైనా డౌట్స్ ఉంటే కాల్ చేయండి నాకు, నేను చెప్తాను. మెసేజ్ పెట్టారు గ్రూప్ లో. సో వాయిస్ రావట్లేదు అన్నది, మ్యామ్ వాయిస్ ఈజ్ నాట్ కమింగ్ అని పెట్టారు. ఓకే రైట్. సో నెక్స్ట్ క్లాస్ మీకు కంటిన్యూ అవుతుంది. సో ఐ విల్ టేక్ ద క్లాస్ ఇన్ నెక్స్ట్ సాటర్డే. ఓకే, సో ఎనీ డౌట్స్ అప్ టు హియర్? టెల్ మీ, అన్మ్యూట్ చేసుకొని చెప్పండి, ఏం పర్వాలేదు. ఎనీ డౌట్స్? సో 13 members means 11 members is there. శ్రీనివాస్ గారు, మనీషా, సౌమ్య, రాఖీ, మానస్, భవానీ, అలేఖ్య, పావని, ఈ భాగ్యరాజు, జానకి, వీళ్ళు రెగ్యులర్ నిన్న కూడా వచ్చారు. సో రెగ్యులర్ గా వినండి క్లాసెస్, కొంచెం మీకు థియరీకి యూజ్ అవుతాయి. ఎగ్జామ్ డేట్ కూడా వచ్చింది కదా, నెక్స్ట్ మీకు థియరీకి యూజ్ అవుతాయి. సో నెక్స్ట్ క్లాస్ విల్ టేక్ ది క్లాస్, వాసంతి మేడం విల్ టేక్ ద క్లాస్. ఓకే, సో నౌ ఐఎమ్ స్టాప్ హియర్.
జూమ్ లింక్ ముందు కొంచెం ముందు షేర్ చేయండి మ్యామ్.
చేశానమ్మా నేను, అందుకే ఈ రోజు 1/2 hour బిఫోరే చేశాను, మీకు గ్రూప్ లో షేర్ చేశాను. నాది సేమ్
ఇప్పుడు వాసంతి మ్యామ్ కి కూడా ఇదే లింక్ లో వెళ్ళిపోతుంది.
గుర్తు పెట్టుకోండి, ఇప్పుడు నేను షేర్ చేసింది డైలీ నా క్లాస్ కి అది సేమ్ ఉంటుంది. సో వాసంతి మేడం షేర్ చేసేది సేమ్ వాసంతి మేడం క్లాస్ కి, అది మీరు ఓపెన్ చేసుకోండి. దెన్ నెక్స్ట్
నిన్న మార్నింగ్ ఒక లింక్ ఇచ్చారు, మధ్యాహ్నానికి ఇంకో లింక్ ఇచ్చారు
మేడం. ఈ 2 classes కదా మేడం, విల్ టేక్ ద క్లాస్ 2 classes.
ఓకే
టూ క్లాసెస్ కి టూ డిఫరెన్స్ ఉన్నాయి. సో ఎనీవే
Okay.
ఐ విల్ గివ్ ది డీటెయిల్స్ ఇన్ యువర్ వాట్సాప్ గ్రూప్. ఓకే, సో 4
Okay, ma'am.
సబ్జెక్ట్స్
Thank
కి
you.
4 లింకులు కానీ లేదంటే ఐడి యూజర్ నేమ్ అండ్ పాస్వర్డ్ ఇస్తాను. డోంట్ వరీ.
Yeah.
ఇప్పుడు నెక్స్ట్ మేడం
Okay,
ఉంది, అది వినండి. ఓకేనా? మీకు ఇప్పుడు నేను
Okay, ma'am.
వాట్సాప్ లో షేర్ చేస్తాను. ఓకే,
Okay, ma'am. Thank you.
ఏం డౌట్స్ లేవు కదా? ఎనీ డౌట్స్? సో 2
No,
క్లాసెస్
ma'am,
అయినా
thank
ఈ
you.
రోజు మీకు రేడియేషన్ బడ్జెట్ అండ్ ఇంకేమైంది మీకు సీ లెవెల్ రైజ్. సో ఈ 2 మీకు ఇంపార్టెంట్ ఎగ్జామ్ లో వస్తాయి. సో నేను మెయిన్ మీకు ఎగ్జామ్ లో ఇంపార్టెంట్ వచ్చాయే మీకు ఎక్స్ప్లెయిన్ చేస్తున్నాను. వేరే సుత్తంత కాకుండా ఇంపార్టెంట్ థింగ్స్, ఇంపార్టెంట్ పాయింట్స్ చెప్తున్నాను. సో అర్థం అవుతుందా నేను చెప్పేది? మీకు ఫీడ్బ్యాక్ తీసుకుంటున్నాను, అందుకని ఏమన్నా డౌట్స్ ఉంటే చెప్పండి. అది కాదు ఇది మేడం అని ఏం లేదు కదా?
No,
ఓకే,
ma'am, thank you.
ఓకే, నెక్స్ట్ క్లాస్ మీరు లాగిన్ అవ్వండి. ఓకే
Okay, ma'am.
ఓకే, బాయ్ బాయ్.